Hello, everyone who just joined. We'll wait a couple of more seconds or minutes until we open it up. In the meantime, I want you to join us via Slido. If you can go to slido.com and input this code. And there should be a first question asking you about your affiliation. It will give us a good idea about the audience and their backgrounds. Okay, so while people respond to the Slido poll, quick bookkeeping. Most people who join other than the panelists will not be able to turn their cameras and microphones on for the time being. I will quickly give an overview about the two projects that are jointly organizing this event, Iliad and OTTERS, for the first 10 minutes, and then we'll open up a discussion session with our panelists for the remaining of the hour. And then in the last 30 minutes, we will have a Q&A with the panelists. So anybody in the audience, in this case, could raise their hand. We can turn on their microphone, or you can type your question in the chat, whichever way you prefer. Audience come from academia, 13% from consultancy, 9% from civil society, very low participation from the tech industry. And I think, Eric, you're the only person involved in law so far. Hopefully others join. Okay. I'll keep the poll running for now, and I will quickly introduce OTTERS and Iliad, and then we'll start the discussion. So one of the projects that is co-organizing this is called OTTERS. It stands for Social Transformation for Water Stewardship through Scaling Up of Citizen Science. It's part of Mission Ocean's first calls. It started earlier this year in January, and it will go until June 2025. It's a coordination and support action funded by through the Horizon Europe by the European Commission, and the funding amounts to 1 million euros. The OTTERS consortium is composed of 12 partners, which spans universities, research institutions, NGOs, and citizen science organizations. And as you can see from the map here, the organizations cover a wide number of European and neighboring countries. So what does the project entail? It aims for social transformation through scaling up of citizen science, both in freshwater and marine domains. We want to help accelerate the adoption of different standards in citizen science projects, and this pertains to both legal issues, legal standards, technical standards, but also when it comes to methods of how the data is being captured and transferred. At the same time, we want to evaluate and assess the effectiveness of citizen science projects on changing citizens' behavior. So it goes both ways. How are the citizens learning while participating in these projects? How is their raised awareness and ocean literacy contributing to behavioral change? Are they becoming more environmentally, say, supportive or responsible individuals? Are they becoming more vocal in policy and decision making, etc.? So an effort of combining best practices from both standardization efforts and from evaluation efforts is what we will do. And these best practices will be summarized in a number of different white papers, guidebooks, toolkits. But we will also work with school teachers, organize summer schools, kind of training for trainers, and help them integrate a lot of these best practices or citizen science into their school and university curricula. We will also try and develop online courses and MOOCs for higher education institutions. So this part about outreach and engagement, but also what we want to do, and this is core part of the project, We want to cluster ongoing citizen science initiatives in the water domain, again, both freshwater and marine, within specific geographic areas. Say there are a couple of independent citizen science projects happening within the same watershed. It could be cross-country projects in different cities. We want to cluster them and unify them under umbrella campaigns, and we're terming the campaigns Spring to Sea Stewardship campaigns. So imagine there's one upstream, and then there's another citizen science project happening in another city downstream, and the third one along the coast, the estuary. We want to see if we can join these projects under unifying themes, help them organize joint activities, help them use each other's different resources, and in a way increase citizens' awareness towards thinking not only from their local perspective, but how water is or water ecosystems are interconnected, even across countries. This might showcase to citizens what they do, for instance, upstream could impact the lives of other individuals and other cities downstream. On top of that, we also want to see how we can kind of increase the adoption of standards across different projects by clustering them together. So I already talked about this, piloting cross-community watershed-based Spring to Sea stewardship campaigns and promoting scaling up of citizen science. Moving on to Iliad, which is another project we're involved in, and it stands for Integrated Digital Framework for Comprehensive Maritime Data and Information Services. It's about creating a digital twin or digital twins of the oceans. The total amount of the project exceeds 18 million. Most of it is funded through European Commission's Horizon 2020 Research and Innovation Program. The duration of this project is 3 years. We started Iliad in the beginning of 2022, and it will span till January 2025. The Iliad consortium is quite large. It involves 56 partners that go across industries, research and tech development, institutions and companies, and end users. Moving on, basically the main aim of Iliad is to provide virtual environments representing the ocean, capable of running complex predictive management scenarios. And we want to use innovative systems and cross-discipline sensors, models, and digital infrastructures for also multi-layered type of decision-making. Since Iliad is in the middle of a dynamic partnership between different ecosystems, projects, and initiatives, we want to make sure the efforts in this project are well aligned with other efforts happening in Europe and the world by using similar standards, APIs, and best practices. And together, we want to have a partnership working towards the implementation of interoperable services and systems and digital twins. So in a nutshell, Iliad involves interoperable digital twins connecting already found ocean data infrastructures, but also bringing additional data from further observation technologies like low-cost sensors and citizen science. We want to develop a lot of different solutions and host them on a marketplace accessible by everyone, where whoever is interested in blue growth, blue technologies, and ocean sustainability could search this online catalog and either download or acquire these services, whether they're free or paid for services. And then we also want to provide solutions to address future societal challenges by assembling a very diverse community around the project and supporting these communities via different infrastructures we're building. Part of that is the Iliad Academy, which will be an online educational tool to learn about all these innovative technologies for blue growth. And another one will be the business technology and innovation facility, which is if you're a startup or you have a nice idea and you want to commercialize your solution, you can go through some training and support mechanisms in order to develop your tool or your business to a point where you can host it on the Iliad marketplace or other places as well. So that's the two projects in a nutshell. And that ties in, both of them in some ways, tie in very well with the three questions that we want to discuss today. First one being building trust in citizen-generated data so that they could be well used for policy compliance and advancement, that this data is not lost somewhere along the chain. The second issue we want to look into is standardization and adoption of novel approaches, including the use of low-cost sensors by citizens, but we could also expand it to similar further topics. And the third one is community engagement in biodiversity conservation and ecosystem restoration projects, and how these kind of grassroots or civil society citizen science projects could adhere to best practices. To discuss these issues today, I'm going to introduce our panelists very quickly. To start with, we have Eric van Doorn from Walter Schücking Institute for International Law at Kiel University in Germany. Until recently, Eric was also a postdoc at the Geomar Helmholtz Center for Ocean Research in Kiel. His fields of work are law of the sea, international environmental law, especially concerning marine resources, the uptake of carbon dioxide, and ocean observing. Welcome, Eric. Our second panelist is Hugo Paredes. Hugo is a prorector for digital transition and administrative transformation at the University of Tras os Montes Alto Douro. I hope I pronounced that correctly, where he is the director of the PhD program in informatics. He's also a senior researcher at INESTech, and as such, he's one of our partners in the Iliad project. There, his interests lie in the field of human-computer interaction and human AI domain. He's authored more than 150 peer-reviewed articles. Moving on to our third panelist, Luisa Galgani from Italy. She's an aquatic scientist mainly focused on assessing human impacts on carbon dynamics in marine and freshwater environments. She studies the effects of plastic and climate change. She has been working in Italy, Germany, and the US. Her research led her to spend many days navigating, which she loves. She studied different seas from the Mediterranean, Arctic, South Pacific, Central Atlantic, and Indian Ocean. And reading that, I'm feeling very envious. She also performs experiments in the lab, but loves being on board in the middle of the ocean most of the time. Welcome, Louisa. Moving on to Robert Atkinson. He's responsible for establishing and implementing best practices for OGC publication of semantic resources and manages OGC Rainbow on behalf of the OGC Naming Authority. Rob holds a master's degree research in computing science from Wollongong University and has worked in academia, heavy industry, NGOs, consulting government, and the private sector startups implementing distributed systems. He's a co-author on WMS 1.0, initial leader of observation and measurements development, and has been engaged in leading edge of OGC and W3C interoperability initiatives since 1998. So he brings a host of very rich experiences to the discussion. Welcome, Rob. And Tom Red, he's the operations manager at Hub Ocean, a foundation with a mission to unlock the power of ocean data. Tom leads activities related to ocean restoration and governance. He is responsible for involvement in European activities and Hub Ocean's role in the Iliad Digital Twin project. Previously, Tom has worked developing marine science, funding programs at the European level at the intergovernmental organization JPI Oceans. His education is in marine science, policy, and law, so very interdisciplinary in this sense, and he can, I think, add a lot to the discussion today. So much for the panelists. I'm going to also introduce my co-moderator for today, Emily Robertson. She's a graduate student at the University of Haifa. Her research is in anthropology and has integrated into her work applied marine biology and ecological research lab, where she studies cultural impacts of jellyfish citizen science projects can have on Mediterranean populations. This has a very multi-species approach. Both human and jellyfish interact with each other in different zones. And that leaves me. I'm Garabet Kazanjian. I'm an assistant professor at the American University of Armenia. I hold a master's degree in fisheries ecology, marine, but also PhD in limnology and freshwater. My PhD was from Humboldt University in Berlin, dealing a lot with also carbon dynamics, like Louisa. I'm currently coordinating the OTTERS project. I'm also leading the development of the Iliad Policy Impact Facility and the aforementioned Iliad Academy. So that said, I want to share with you, the final results that we have for the first poll on Slido. If you haven't joined yet, please, you can either scan this code or go to slido.com and add this number and you will be in. So we see the majority are from academia, some from consultancy, some from civil society, a bit from local authorities and tech industry. I'll move to the second question on Slido before I open up the discussion. So maybe you can already start answering that. What is your interest in citizen science, in organizing citizen science campaigns, making use of citizen science data, assessing the impacts of projects on citizen awareness and behavior, technical aspects, legal aspects, etc. So I'll let you get along with that, and I'll stop sharing my screen so I could interact with the panel speakers. Maybe it's good to start with a broad overview from a policy perspective. Since OTTERS is also a Mission Ocean campaign, the European Restoring Our Oceans campaign has three main policy objectives and two enablers. The policy objectives are protecting and restoring ecosystems and biodiversity, preventing and eliminating pollution, and making the blue economy carbon neutral and circular. But to achieve these goals, there's a lot of need for observations, and citizen science could be one of the enablers in this sense. To the point that earlier in July in the fisheries seminar, we heard some comments by representatives of DG Mare that they're expecting to have about a quarter of their total marine observations coming from citizen sources, citizen-generated data. And eventually, they also want to form citizen panels for integration of citizens in the decision-making. Very ambitious goals, but maybe there also lie a lot of big challenges to reaching these numbers. So maybe first I turn to Eric with this question. Maybe you can give us, as somebody who works with the law of maritime law and regulatory framework, maybe you can give us a quick overview about the upcoming targets and the status where we are now, and talk a bit about policies related to ocean sustainability, but also mention some of the challenges that the sector is currently facing. And finally, how can citizen science, in your opinion, contribute to helping meet those targets?
Thank you very much, Garabet, and also Emily for the question at first, and also for inviting me to this great panel. That is quite a lot that you just asked. So I'll try to keep it short. But normally I start with never let a lawyer talk because they can talk forever. So please cut me off when necessary. I think it's important to put out there first that the EU can actually only regulate what the member states allow the EU to regulate. So when the EU does not have a clear legal basis to regulate something, it will mean it falls back to the member states, right? So the member states actively have to transfer the competence to the EU. In some cases, they have shared competence. So both the member states and the EU can do something. But that is an important point. So it depends a lot on which topic we talk about, if the EU can regulate something and what they can actually achieve. So there's, and different topics, different marine topics have different legal basis in the treaties of the EU. So before this Mission Ocean existed, there were, of course, already a lot of policy instruments and regulatory instruments from the EU, some of them very old. For example, the common fisheries policy, which is done on the EU level, right? So the member states don't have much to say about this. So that is a complete EU thing. Now also called conservation and management of marine biological resources. That is completely EU. However, many of the data that need to be collected for these to achieve these goals, and Garabet mentioned already a couple, right? Many of you will probably have heard about the Marine Strategy Framework Directive, which aims at achieving a good environmental status. And then they list, I think, 11 parameters for which you need data in order to achieve those. Interestingly, the EU is not responsible for that, right? In most cases, it's actually the member states that then are responsible for collecting these data. There are exceptions, but in most cases, that is true. So we have before we had this mission Ocean, there was something called, which still exists actually, the Integrated Maritime Policy. And under that Integrated Maritime Policy, a lot of the other policies for the ocean from the EU are categorized, so to say. So the Marine Strategy Framework Directive falls under that. And it's important to keep in mind that the initial focus of the EU has always been an economic one. And of course, this is broadening out more and more to environmental issues because we no longer can see them separately. But if you go quickly to the EU website, for example, and you look at Directorate General Mare, so DG Mare, which is responsible for the ocean part, you see a lot of blue economy, blue economy, blue economy. So that is one part. Fisheries is one part. Marine Strategy Framework, they do a lot of marine spatial planning as well, but marine spatial planning is one of those things where the competence is also partly at the member states, so there the EU can only harmonize. So that is, I think, the nutshell. There's a lot out there. You just have to see what is in Brussels and what is in the member states. Back to that data, which I mentioned earlier, as I said, in many cases, the member state is responsible for this data, and then the EU has sometimes a hard time getting these data, right? And I think that there's not enough harmonization between the member states, this is just my personal opinion, in order to get these data. That is something the EU could achieve, but that is, and then it has to be done by researchers, right? By you or me, more or less, or it can also be done by citizens, right? And I think there is a very nice opportunity because there's lack of harmonization between the member states. There's a nice opportunity for citizen science. Lawyers always like definitions, but it takes too far to probably come up with a definition of citizen science now, or even citizen. But that might be a nice option where this will actually fit in. So in a nutshell, data are needed. How are we going to collect them? Partly through the member states. The EU doesn't collect that much data themselves. They do, but not enough. And then citizen science could probably fill that gap, although that's not really regulated yet. So that's the next challenge.
So, Eric, would you say that these inconsistencies between the member states and the EU are the main challenges, or perhaps the bottleneck issue for using citizen science data to advance policy? Or is it perhaps more of an issue with trusting, like ensuring the data quality that's been produced by citizens who are not, in some eyes, trained scientists? Or is it perhaps data accessibility, the inability to find similar data that you could reattribute to other aspects?
Yeah, thanks, Emily, for that question. That probably allows me to make a distinction, at least legally, between the data collection as such, which is often also called ocean observation, right? So collecting the data as such in order to get that data. That is one legal regime. Actually also a couple, but that is one part. And then as soon as you have these data, the transferability, the interoperability, who has access to these data is a whole different ballgame, so to say. So then a whole different legal regime kicks in. Honestly, my expertise is more on the former, so on the data collection and how that is regulated. And I think there's many other people in the panel here that could say more about the latter, so the actually transferability and interoperability of the system. And what I was talking in my answer to Garabet's question was also mainly about this data collection. And there, I think there's a lot to gain. so far, if you go out on the ocean, you need to have permission to collect data from the member state, from the coastal state in whose waters you are. And in many cases, that is actually up to 200 nautical miles from the coastline that you have to ask for this permission. And it doesn't matter if you do that within the EU or outside the EU. So if German scientists go to France or they go to the United States, they will have to go through the same procedure, which is weird because apparently it's not easier within the EU to actually ask for these permissions. That is already an issue. That has nothing to do with citizen science. Where citizen science kicks in is, for example, this has been done by my former boss at Geomar. He wanted to measure something on sailing yachts. So you actually put, he wanted to measure carbon, I think, if I'm not mistaken. Now the regatta itself was not necessarily interested in carbon, and they were interested in plastic, which, as Louisa knows, is much more catchy than carbon, right? So easier picked up by the media. He also did measure carbon, but you never know where these sailing yachts are going to be. So in which coastal waters are they going to be? And if you see this as an example of citizen science, and you have to ask, which are under the current rules is the case, ask 6 months in advance your permission, and you actually don't know how the wind is going to be when the regatta happens, then you have a big issue, right? And this is just one example, which actually, which we are working on now, what could be a solution there? Because what makes it even more difficult is that those sailing yachts are sailing under different flags, right? So some of them all it has to go per flag state, where you actually ask per coastal state what you're going to do. So what I try to point out here, this is pretty impossible. And this would be the case for a lot of citizen science, actually, when it's out on the open ocean, which makes it very difficult. So I think that is where the challenge lies at the moment from my point of view.
Very interesting. Thank you, Eric.
Thanks, Eric. You talked a lot about permissions and measurements, etc., of data, but I'm going to turn to Tom now. And as you're someone who's developing Hub Ocean, which is an ocean data platform that ingests a lot of citizen science data, can you tell us a bit how that data is licensed, it's transferred, managed, how is it hosted, and maybe also a bit about the challenges in that process?
Yeah, maybe I'll speak to the challenges first, because I actually had a look and I don't think we host any citizen science data on the platform yet. Okay. Which is also fair. We don't host a huge amount of data anyway. But I think then talking about the challenge of getting citizen science on our platform. So just a very brief sort of introduction to what Ocean Data Platform is. It's a cloud-based API first geospatial compute platform for ocean data. There's a lot of technical words in there, but basically just somewhere where you can put ocean data and play with it and do analytics in the cloud. So, you know, we see a huge value in citizen science data in augmenting other forms of data. So we work with a lot of open data, obviously, and industrial data, which is shared through the business collaborations that we have. One of the challenges, I think, well, there are a few challenges. One of them is knowing what citizen science data is available. Typically, citizen science data tends to be generated on a per project basis, and I think that can be a challenge, because when the project ends, there's a sort of a question around who looks after that data and what the legacy of that data is. So that's one issue, and who promotes that it's there. And then the other thing is how do you connect to data that is stored and hosted in like so many different ways. You know, the worst case scenario, it's on a hard drive on someone's computer, not anywhere available on the internet. So how would we ingest that? Best case scenario, it's probably on somebody's server, but then we can't write individual pipelines, data pipelines. That's how we connect to data for every single source of citizen science data, even if we knew where it was. So that's a challenge, but that's something that we're working in the Iliad project to do, is to develop tools that would enable easier data sharing from from citizen science projects, to bring those into an environment where you'd be able to work on it and do analytics in one place. So that's for me, that's a really exciting opportunity in the Iliad project, and I'd be happy to talk about that further. But does that answer your question, at least to begin with?
Yeah, somewhat. So in terms of accessing the data, there seem to be a lot of challenges, but what about licensing the data? Are you allowed to transfer it from one place to the other?
Yeah, so one of the probably the better things about working with citizen science data is it tends to have fairly open licenses for use. So I think probably a lot of people will be familiar with the Creative Commons licenses. That basically is a standardized list of different licenses that allow you to use data. For us, of course, the easiest one to work with is free for use in any way, because then there's no sort of like legal restrictions that we have to go through to think about, okay, because if we have data on our platform that is for non-commercial use, then we have to put up, you know, a policy to stop it being used commercially, and if data is on the platform that's for any kind of use, then it's great, then we could just let people use it as they want. And I think probably citizen science data is probably more open than other types of data, so that's great. But of course, like that license needs to be in the metadata of the data when we find it. So I think best practices around describing data sets is really, really important, and for us at least. Yeah.
Thanks, Tom. I'll turn to Rob now with the discussion. Tom mentioned a lot from a top-down perspective as a data collector, let's say, as a hub, for lack of a better term. But what about bottom-up? How can we ensure some layer of interoperability, some layer of standards where if you collect the data, it could very easily be read or used by different platforms, whether that's Hub Ocean, EmoteNet, Iliad, Edito, etc.
So that's obviously a big question. And as we've sort of heard, there are many, many aspects of interoperability. We've just been hearing about some of the legal aspects, and there are things like the European Interoperability Framework, and they basically break down legal, operational, semantic, and technical interoperability. I'm just going to share my screen and just show some of the work we're starting to do in Iliad around supporting citizen science in terms of interoperability. And if I get this right, it'll be that screen there. And we can see a little breakdown here. So when you break the problem down into a bunch of different pieces, you sort of start in the bottom left. There are sort of foundation models of how we look at the world. And then we have this concept of cross-domain models, which are things which are very, very common. And this is where the Oceans Information Model in the Iliad is developing a semantic model made out of standardized building blocks, observations and measurements, provenance, data cataloging, vocabulary, a series of standardized things. But there are also these standardized implementation patterns where there are general software and general APIs are available for those. They're great, and there's developer tools, and that gives a baseline of common tools. But to actually apply that to a real-world problem, you need to sort of go deeper into levels of specialization. So one of the first things to do is to connect up the cross-domain models we have with those implementation patterns and create specific APIs for dealing with certain types of data. So again, we can do that, and that can give us some reusable validators. And so this is the software support layer. Again, we're still not at a stage yet where we have got data which is interoperable. And ultimately, we want at the top level, we want applications to be able to share data. We want citizen science collection applications to be able to share data with consuming applications to deliver results. And whether that's directly through direct interoperation, or whether it's because we can have testable transformations, we know how the data goes from one to the other. Our goal is to achieve that. And that middle layer is where things like Hub Ocean and other pieces of infrastructure come in, supporting standardized APIs. They're effectively the platform that create a degree of technical interoperation. And then what you have to do is you have to build the semantic interoperability. Does my data meet this need? So the more we can push the technical interoperability into the infrastructure so that it's there by default, and the citizen science and other types of science applications don't have to spend too much time designing that. They're just exploiting it. The more we can push it up into what's the particular constraints I want to use. I need this field. I need that field. The extra fields I need. Now I need here's the vocabularies I want to use. So I'm just going to quickly dive into very quickly here an example for we're building out, and this is another best practice, is actually testing as you go, making sure the documentation process is testable. So we're building this, for example, the jellyfish pilot project in Iliad is a profile of a citizen science, a generalized citizen science profile, which is a profile of the oceans model profile, which is a profile of these underlying patterns, which is OGC standard, is an OGC W3C standard, sense, observation, sampling, and actuation. So that's a sort of little architecture. What it looks like in practice, if I go and have a look at one of the examples here, and is that we basically can have example data. And here, hopefully that's readable. But basically have sort of very typical sort of example data that comes through. And you can sort of see we have things like, okay, there's an observed property, which is part of the standard, and there's a code. And what does that code mean? Well, that's where we basically add this sort of the semantic annotation layer. And what we'll see here is the observed property has been turned into a full URI, and it'll probably make a fool of me, never do anything live. And this should actually link to a, what have I done? I was, because it's got that in there.
Yeah.
That should link to a it is going to make a full. Sorry. Okay, no, I'm wrong. I thought that this was going to a live. Anyway, we have vocabulary servers being set up for all the properties that we use. I'm not sure quite why that doesn't work today, but so the key issue here is that we have these examples and we have tools for semantic annotating them. That's really quite hard to do. But if we do it just as that top layer where we just do the schema, for example, references the underlying schema, that's where all the complexity happens. And then all we do is you say, this is the result. This is the little pieces of things we need. I want quantity of jellyfish, density of jellyfish. I've got just a little bit of extra syntax on top of the underlying standards, and that's compiled into the full schema, which supports the full set of data using the standard. So the trick is can we isolate what's specific about the project from all the underlying commonalities, because there's a lot of complexity in those. And if we then look at the validation process, which we run through, here's our example we just had, which was that turned into the semantic version of it. And this is the interesting part. As an example, basically, we go through a series of validations. We validate against the schema. So we can have validators to support the process, but we're also inheriting business rules from the underlying standards to make sure that, for example, if an observation is in a collection, either the observation or the collection must tell me what's being observed. Now, so there are these sort of logical rules about what data do you need to be present, and those sort of things. That's just hard to do if you're starting from scratch. So the concept here is to leverage well-known structures and get this sort of baseline of interoperability between systems, the infrastructures that we have working. So, for example, make sure that we can talk to GBIF. Make sure that that our baseline always interoperates with GBIF, no matter what you're choosing, whatever species you're choosing to measure and whatever properties you want to measure, the underlying baseline is going to be compatible with linking to GBIF or linking to whatever other systems we want to talk to. So I guess that's the bottom line. I hope that's coherent. If you try to design a system from scratch, it's incredibly complicated. Too many aspects to get right. But if we layer it, then each project can leverage some commonality. And so developing tools to support that is basically what we're working through. And we're co-designing the tools as we co-design the Oceans Information Model and the platforms in Iliad. And so we're sort of exercising this against that scalability criteria that you introduced at the beginning. Now we've got this concept of registers of building blocks. Now we can start looking at reusable patterns. We've got we do have now. There's things like SenseThings API, which is another API. The standards for these are these are long, complicated beasts. No one in the average citizen science community is going to read that standard and understand how they use it. So that's why we've got to put this lightweight profiling layer on top of it. So all that works. You just need to care about the particular 3 things you care about for jellyfish. Let's add that to the system, and then it'll work. And your system should interoperate with those other platforms that you sort of, the experts have implemented to support interoperability against your target application goals. So I'll probably stop. That's more than enough time, I think, on that. But hopefully that gives you some idea that it is complicated, but it can be broken into pieces.
Thank you, Rob. And one of those pieces that you mentioned specifically is how the data quality itself can be held up to the standards that interoperability needs to make it accessible across all of these levels. So who specifically, both regionally within the citizen science program, ensures that the data that is being collected for the projects is accurate and up to date and collected to the standards that we need to apply it to whatever oceanographic model. So obviously projects have a large proportion of the responsibility to check their quality of their work, but there are other safeguards available hosted on, say, HubOcean, eModNet, or CDataNet that could be used for policy compliance and decision making. Hugo, could you address any of these topics?
Yeah, so good afternoon, and thank you very much for the invitation, Emily and Garabet. So, and regarding data and looking at data, I would say that first we need to look at the source of data. So if we are getting data from sensors, in citizen science, of course, from people, but we can also have some synthetic data. But when we get the data, then we need to create or have a workflow for the curation of data. And in this process is where we must be aware of how this process should be. It could be automatically just based on AI, and we can just rely fully on AI. But actually, if you go to the ethics of AI, you know that you need humans in the loop. So you need to put humans controlling AI, supervising AI. So this is another step where citizen science can have a very important role in the process, is to put humans in the validation of data. And of course, for this, you need to have citizens that are trained for that, and you need the education and the training of the users. And of course, this is another process that I will probably talk about it later. But we also have the experts, and the experts can also contribute in this process and can help this data validation. So my point here is, So we will have a workflow for data curation, and this workflow for data curation will have many steps, and these steps should involve both automatically processes and human processes. And in these human processes, we can have experts, we can have citizens trained, well-trained for doing that. We can have the crowds working on this. And when we use crowds, we will have statistic methods, we will have lots of data for the validation. And of course, we can combine these with AI, getting our results. So the quality of data should be a process, not a one-step process, but a complex process that can get us from the source of data to a curated data that we can trust. And of course, we can ensure that it can be used and could be standardized and adapted to the interoperability of data.
Thanks, Tom. I don't know, Rob, if you want to add something to that, or
in terms of that, there are two other parts of quality that we are working on in terms of scalability. One is that there is an ISO standard which is developing a concept for a register of data quality measures. So standardizing the way data quality is described, and particularly in terms of spatiotemporal sampling, that sort of thing, is an area where we can provide a standardized building block which will help. I mean, you still need to understand your own science in terms of what are your quality targets, but the standardization of how you describe them is something we will support with building blocks in our cross-domain model in OAM. And the second part of it, I mentioned also provenance. And one of the key markers for quality when people are looking at data is actually understanding how that data is being used by other people. Now, what is it that's safe? What trust do I have in it? Quality and trust, I mean, they're very closely tied up. So we think that actually establishing a standardized way of describing the provenance of data as it goes through these systems, so you can see how data is being used, and you can see what type of data that certain models need, should again provide a baseline for the scalability. Doesn't solve all the problems, no single answer ever does, but at least it's a basis for scaling it up.
Thanks, Rob. Maybe I'll take a short break from the standards conversation on standards. I'll show everybody. Ooh. I lost my Zoom controls. Here they are. The results of the second poll we ran. So most people are actually interested in making use of citizen science data, but also related to technical aspects of citizen science data. So I think those two are quite interlinked, and that's why we see the two highest percentages. Assessing impacts of citizen science projects and citizen awareness is third, and then organizing citizen science campaigns, about 1/3 of the participants are interested in that. Legal and ethical aspects is, we don't have a lot of lawyers, I guess that's comes at a lower priority. So I'll share with you the third and last poll, and this should also facilitate maybe the Q&A after our discussion. What challenges have you faced with citizen science campaigns if you've been involved as an organizer or as a participator? This is an open-ended question, but obviously with limited character set. So whatever challenges you can think of or you want to have discussed towards the end of this session in the Q&A, feel free to drop them here. That said, I'll get back to our panelists and we move forward. I don't know, Emily, do you have a question in mind?
Yeah, excellent. So going back to what Rob said about knowing your own science, this really applies to the citizen scientists themselves. So Tom, could you speak to us about perhaps how citizens can use platforms such as Hub Ocean to increase their own ocean literacy, or students hoping to use data sets for coursework, training, or other things that might apply to them?
Yeah, of course. And I think going back to one of the things that I originally talked about was knowing what's available, and what data already has existed is probably a really big challenge to solve within the citizen science community. I would have thought, because if I think the example of students is a really good one. If you're starting a project in a certain area of the sea, the first thing that you're probably going to want to do is to see what's been done before, and you're going to do a literature review and sort of do all those kinds of things, and then you might find some sort of like interesting citizen science projects that kind of look like they might have some interesting data. You then have to go down the pathway of like finding, oh, okay, I found the website doesn't work. Where do I access it from? It's not in eModNet. So the sort of the accessibility, I think, of citizen science data is a real challenge, and probably a barrier to using it. And so that's, again, sort of something I think which we would like to do more on in the future, is surfacing citizen science data and hosting it in platforms like Ocean Data Platform, or others, of course, who would do a similar thing, to make sure that it's there and it's ready to use, so that when you kind of like, you decided as a student, okay, I'm really interested in this area. Oh, look, the data's already there. I can bring it into a computing environment. Ocean Data Platform is at the moment has workspaces that are Python based, so you do have to be a bit of somebody who has a background in coding or has some experience in coding to work with that data. But as time goes on, as we develop the platform, we hope to bring on more functionality for just playing around with data in a easier to use format. But I think, like, going back to that issue of surfacing data and making people aware of what already exists, that's super important. And I think just talking to the Otter project, which I hadn't looked into before, so this is a great example of why these webinars are so important. Bringing initiatives under umbrellas and under collections is already a brilliant first step in aligning across sort of a lot of disparate activities. So I think that's a really good opportunity for you in the Otter project. And one of the things that I hope you do consider is sort of how you create a legacy for the data that is produced within the project and the projects that you work with, to make sure that when the project finishes and everybody goes off and does different things, that it's in a repository somewhere that it can be found for future people to use.
Mm-hmm. Yeah, that's a great point, Tom. One of the objectives of the project is to create a lot of easy-to-use toolkits and guidelines based on some of the standards and best practices we could recommend. A lot of these will be hosted on the European Citizen Science Association's network and resource hubs, so they will be there after the project ends. But one also side outcome of clustering a lot of different ongoing citizen science initiatives is if, say, a citizen science project, after 2-3 years of a lot of citizen engagement, training citizens, collecting data, ends up without funding to continue. Most of the time, or unfortunately sometimes at least, that data gets lost. Engagement with citizens sometimes is completely broken down. People get demotivated, they don't want to continue. But if you have other projects happening in the same region, they might be kind of eaten up or kind of moved into the next one. And sometimes co-funding could be secured if several different initiatives join forces. So there's a lot of positives that can come from these clustering initiatives. And maybe since we went from higher up, from policy all the way to organizing citizen science projects, I'm going to give the floor to Louisa, since you're somebody who has designed a number of citizen science projects and worked with local communities. What was in general the challenges? What were the challenges that you faced in engaging citizens, for one, but also in determining what methods to use in measuring specific parameters, identifying locations. I remember you had told me once citizens themselves were interested in taking measurements from nearby their houses because that was something very personal for them. So how do you involve citizens in co-designing phase of your project to start with, and then how do you agree or define the standards, the methods you want to employ in this? Have you found some place, some repository, some, I don't know, resource where you go and check the different standards available and decide accordingly, or is it more ad hoc?
So, hi everybody, and thank you, Garabet and Emily, for having me today, and thanks for the panelists because I learned a lot of interesting things today from the discussion. Well, my first citizen science project started in 2016, and it was, I guess, it was the first one in Italy on a larger scale, and it was focused on freshwater environments. And since I didn't want to invent something, because I thought there's no use if these data are just on a local level, then I joined a bigger platform, which was Freshwater Watch at that time. So basically the data collected by my about 40 volunteers were going into this larger database, which is an international database on water quality worldwide. The only thing that we added to the project was monitoring of plastic pollution along the rivers and on the shores of the lakes to track macro objects that could potentially end up into the sea. This was, as Eric said, plastic is a catchy topic, and a lot of people in the community where I was working were first interested in learning about this, and then we had training. So I followed the guidelines of the organization for training the citizens. They had to do an exam, a little exam, a little test to see whether they understood. Then we went out sampling together, and then we interpreted the data. So we were talking about nutrient pollution, talking about plastic pollution, and then we shared those results with the local government. When it came to choosing the sites, we actually first looked at where the Environmental Protection Agency had some sampling. And then we tried to fill in the gaps by adding, for example, 4 points along this river where the Environmental Protection Agency only had one monitoring site. And then of course, there were citizens interested in their backyard pond or lake. And so we, of course, designed together those places and how many times per year they should have taken samples. And the challenge is, I think in general, in all citizen science project, is gather people that are not super green. I mean, the people I was working with were already very conscious and engaged, and they wanted to do something. So it was relatively easy. And I've seen that in other citizen science projects that I have been involved into, that it's the big challenge is trying to get people who usually don't care so much about the environment into like caring more. So maybe starting from schools, and then kids can talk to their parents. It's also a matter of time, because I was asking the citizens to collect samples at least 5 times per year. And some of them were so motivated that they actually collected samples not only on one site, but on multiple sites. And they did this project for 2 years. The thing is that they need a constant engagement and follow-up and feedbacks. So we had a WhatsApp group, and we gather regularly to analyze the data, and then we had some other events that we prepared together, like, for example, a cinema event where we were showing movies about different environmental topics in the local cinema. So, and that was something very nice because it creates a link, a social link as well. I was not just the one asking them to gather those samples. I mean, they were the first one interested in getting those samples and doing something for their environment. On the other side, when we tried in another project to apply, that was another part of Italy, we tried to understand the perception of people first. So, of course, we had citizens collecting data, like environmental data about water quality, but we tried to make a survey in schools, starting from schools, and we also had families and adults and parents trying to answer the questions about the emotional connection they had with nature, to understand what is the audience that we have here and what do they need, what do they feel, how do they feel when the environment is in a good condition or in a bad condition. But and we actually have, I think, 1,000 questionnaires or something, but we are not psychologists to analyze them. So we are just still looking for somebody to help analyze those questions. But that was interesting because it was a survey on the connectedness to nature. So try to, at least people they had a first step into understanding, okay, just think about it. How do you feel when you see your environment in a certain way? And I think this could be applied as a side aspect to promote engagement, because then people are really taking, helping in taking samples for a longer time. So besides the resources, like economic resources that are needed, they also need a motivation to go on. And there, I think it's only if there's some kind of social interaction with either a trainer or a researcher, somebody who can, of course, also validate the data, because I think that you need to have somebody there who says, okay, this is a weird data collected. Are you sure about it? Maybe there was something wrong. Maybe you didn't, I don't know, maybe you clicked the wrong button on the result of, for example, nitrate or phosphate or whatever. So that was my experience. And in terms of, I'm now involved in a citizen science project on plastic, but on plastic, I have to say that already as researchers, we have a lot of issues trying to standardize our sampling methods, approaches, what is a microplastic, how should we sample, like below 300 micron, above, whatever. So it's already difficult to standardize in terms of research. So for citizen science, I think it's tricky because everybody goes and has a different way of taking samples. And so I think it's really urgently needed to have some guidelines to perform those kinds of studies.
Yeah,
Thanks,
Louisa, you're absolutely right, especially within the aspect of we all need to have some kind of guide that we follow for what type of data is collected, what measurement and how it's collected. Even within the citizen science projects around jellyfish, we have and know of 10 or so different initiatives all throughout the EU and other parts of the world that are collecting jellyfish citizen science data, but we're all doing it on different levels. Some are measuring how many jellyfish that an individual sees within a square meter, but how do you ask a lay individual to be able to identify what a square meter looks like in open ocean and then tell you how many jellyfish there are? So we've been collaborating with some of these other initiatives to try and form a very basic layer of understanding on how we're going to measure, how those measurements can be scaled up or scaled down to increase interoperability that will ultimately go into ocean infographic models and things like this. But also within the perception of people, my own research within Malta, which was looking at how jellyfish citizen science projects can impact people's feeling towards not only the animal itself, but also nature, really kind of showed that people are not unaware of what goes on in their immediate environment, especially within Malta, where everybody's backyard is the Mediterranean Sea. They are observant of the types of fish that coincide with jellyfish blooms during the season. And some of these peoples, particularly those who are pensioners, have such interest and desire to keep or return the state of the nature that they once knew back to what it was, are these key advocates that we should be asking to come forward and help us develop policy, help work with the people in charge of regulating when fishing can and cannot occur because certain species are there that they know of only because of a citizen science project. So it goes that way as well.
Thanks, Emily. I had a couple of more questions noted down, but since we're already in the last 30 minutes, I'm going to ask one more and then open the floor to the audience to ask questions. I think it's a fact that most citizen science projects aim at collecting physical, chemical, or biological data, but there's also a lot of other types of local knowledge, whether that's traditional, social, or based on personal experience, that could be very useful if captured. And it could be very useful for decision makers to see how people are reacting to new regulations and such. Maybe in marine spatial planning, this is a bit better done in that a lot of different stakeholders come together to discuss and plan together. But for instance, in common fisheries policy, this is almost not the case at all. How can citizen science projects in any shape or form be used to also capture this type of information? Maybe Eric, you can give us some overview on this, but I'm opening the floor to everyone as well, whoever from the panel speakers wants to answer this question.
Thanks, Garabet. Then I will try to keep it short. Yeah, I think this is, especially outside Europe, there's this been, I don't want to offend anyone, but especially outside Europe, I think there's a lot of experience with traditional knowledge, right? And also with indigenous knowledge, for example, and the integration into policy. And I'm glad that you mentioned marine spatial planning, because this is actually one of those examples that a lot of stakeholder involvement is started with straight from the beginning to get a lot of buy-in, so to say, from the stakeholders. Now, I saw that Rob studied in Wollongong. I mean, the Australia, the Great Barrier Reef Marine Park is an amazing example of where they, in order to do the planning of what was allowed, which activity was allowed where, they organized more than 1,500 town hall meetings in order to collect stakeholder involvement. And that's a huge operation. And I think it can also be almost drowning if you have so many people there or so much input. I think the key word in this case is legitimacy. So I think it creates a lot of acceptance of policy if you actually get these people in straight from the start. You mentioned fisheries, and there has been traditionally always a bit of a fisherman or the fishing industry found it hard to accept certain policies, which were based on science, and the scientific data not always matched their local knowledge. Although the science was traditionally also partly based on the actual catch data from the fishermen, right? So it's bycatch data, for example, were almost exclusively done in the past on the basis of on catch data. So there's that mismatch, and I think it is. So I would agree with what you said. So I think there's a lot to do there, and I think if you say that the stakeholders and the science they collect, so to say, is also, if you would categorize that as stakeholder science, it might hugely, especially in the fisheries industry, but in many other industries, hugely increase the legitimacy of the policy. And this was exactly the plan with marine spatial planning, right? So there's the UNESCO has published a 10-step plan on how you should conduct marine spatial planning. And this is all about stakeholders. So straight from the beginning. And so I think that's a very important point. As I said, keyword legitimacy can exponentially improve that.
Thank you, Eric. I don't know if Hugo or Luisa or in the meantime, I can read some of the answers we received from Slido in terms of challenges faced. There's 5 statements: data analysis and interpretation, could be a challenge. Data standardization is another one. Lack of a standardized protocol for uncritical consideration. Lack of a data sharing portal. We discussed a few here. But yeah, maybe something specific to citizen science was what was in mind. Guidelines were not clear and easy to understand. Collaboration and coordination. So a number of very wide challenges stated. Any other questions from the audience? Feel free to type in the chat or raise your hand up and I'll make sure you're unmuted. Oh, Ehud is. Okay.
I'm sorry I was late to this meeting, so I'm not aware of the first session, but I'm in the business of cultural heritage. And in cultural heritage, we have a kind of a natural collaboration with the public. I mean, we are very few underwater archaeologists in Israel, and we have 200 kilometers of coast and also inland waters. So few archaeologists cannot take care of all these areas, and we rely a lot on citizen science. I mean, we publish all kinds of posters, post stamps. We give lectures voluntarily in diving clubs, in schools, etc., in order to raise public awareness. And the only thing we want from the public is if somebody locate or trace considerable archaeological find at sea, just to report the authorities. And this way we get actually most of the finds, most of the significant finds along the Israeli coast were discovered by citizens, swimmers, amateur divers, professional divers, Navy divers, etc. People who just went to the sea, and for some reason there was an erosion and an exposure, and significant finds were discovered. Just in the last year, there was a few months ago in an area which is a municipal beach in central Israel, a whole cargo of marble was exposed and discovered by a swimmer. Not even a diver, not even a snorkelist, a swimmer. He was swimming in an area where he used to swim for many years, and suddenly he saw blocks of marble, of 10-meter long blocks of marble, and it was a whole cargo, Roman cargo of columns and architectural elements from originating from a Roman ship. So this happens only a few months ago, and this is a very good example of active citizen science. Actually, we don't have protocols, and we haven't developed the protocols in order to do it, but it comes naturally. We are in tight connections with the public, and every discovery is reported to the Israel Antiquities Authority, and they have the ability to take care of it, to document it, and if necessary, to take it out of the water or to leave it as is as a diving site. This is just to add some dimension to this citizen science. And the citizens, they help us to build the database. Considerable amount of our database that we are building in the framework of the Iliad is based on knowledge which was received from fishermen, from divers, and from the public.
Thank you, Ehud, for sharing that experience with us. It's something I personally hadn't thought of before, but it's quite interesting. If there aren't any questions from the audience, maybe I'll go ahead and ask another one. We talked a lot about standards. We talked a lot about best practices with regards to aiming citizen science projects to collect the data in a way which could then easily be integrated into, say, repositories and digital twins, etc. But we also talked about each project being very, very difficult or different. So maybe I'm asking too much here, but I would like to have as some sort of conclusion, where can we draw the line? We know that Emily mentioned jellyfish projects. I mean, we're talking about one thing, jellyfish here, and they're so diverse, the projects, they're collecting very different things. So in terms of, and this also falls within the objectives of authors and creating these easy to use toolkits and guidelines for new projects to pop up to use. So what can we aim to achieve in the sense that what type of recommendations and what type of toolkits can we provide within each domain, obviously, to new projects that might start in the next months or next years, in guiding them into the right direction? What is too much and what is too little in this sense?
I might dive in here in that the sort of history of software development has been one where complexity always keeps growing, and we're always trying to find a way to do what we call encapsulation, trying to find a way of holding all the complexity. Like when you hit a PowerPoint into a wall, the complexity of how electricity grid works is beyond anybody but a few very clever electrical engineers who understand. But you kind of know how it works. You basically you've got these sort of points where you can simplify the problem. And I think that in terms of how much variation, there are a number of very, very common patterns. And this is kind of what we have with the Oceans Information Model. We kind of know what those common patterns are. And therefore, building better tools, and that's where the Iliad Academy and the OGC Academy itself are working hand in glove to say, we will be looking at building those tools to add in those extra bits and pieces. Now, you know how the electricity grid works. What are your options for designing a toaster? Okay, and you simplify it down. No, okay. But if you have to design the electricity grid every time you build a new toaster, it's impossible. So I think the toolkits, we can definitely provide ways of documenting, validating, provide examples. Providing examples that are actually tested is a key issue. So we're putting a lot of effort into tools just to say, okay, does my data meet the needs of that external system, for example? Let's validate that. It shouldn't be a technical problem for someone to do that. They should simply be able to think through what vocabulary do they want to put into these slots in the data. You're observing something. What's up? Who's defining the observation procedures? Make sure there's a simple process where the descriptions of those can happen and the data can link to it. If users have to read huge documents, they have to find all those many documents, and then those documents
not going to happen.
Yeah, it's impossible to do that. So the guidelines just need to be it's very easy. You basically get a spreadsheet that's already got the column set up to use the right vocabulary. You don't have to think about it.
I see Tom has, thanks, Rob. I see Tom has his hand up quickly, and then we have a question, I think, from the audience. Go ahead, Tom.
Yeah, I just wanted to sort of come in on a bit of what Rob was talking about, that sort of simplifying, or not simplifying, but hiding the complexity behind something that is a simple interface is really, really important. And I think Rob at OGC is doing really, really good work at working through some of those issues. And within the Iliad project as well, we're trying to sort of develop tools for citizen science users and others that are simple to use, but that are actually doing some quite complex and interesting things. And I think one of the things that's really important there is co-development of these types of tools and engaging with actual people who are doing citizen science and the software developers to make sure that we don't sort of go and do our own thing, because that's always like a, you know, everyone loves doing their own thing in their own way, but it's really important to like bring it back and make sure that we co-develop these kind of things, which we have the opportunity to do in projects like Iliad, which is great, and we should highlight that as well, of the importance of those kinds of activities in these projects.
Thanks, Tom. Hugo, very, very quickly.
Sorry to intervene just now. I know we have a question, but just I would say a provocation on these, because we have actually the experience from several projects. We have platforms where we have shared this experience, but we need to now to get this together, so to systematize this knowledge and to create this knowledge. So something like ChatGPT. So we just go to ChatGPT and ask him, so I want to create a citizen science project on these. So what should be the guidelines I should follow? So I would say this could be a way to have artificial intelligence looking for patterns, looking for this data systematization, so we can evolve, and of course having some assistant that can help us. So I would say, if you ask me if I have a vision on this, I would say this could be a vision on how we can have these tools to help us in our daily lives to create new citizen science projects.
Thanks, Hugo. You're truly the AI representative in this panel. Joel, you had a question? Yes.
Yes, hi. Joel, master student at University of Gothenburg. Me and Johnny here are in a group that uses AI, believe it or not, with citizen science for species classification of subsea images in a project. And I don't have very much experience with other kinds of citizen science, but we use this Zooniverse platform, and that we think works very good for keeping it in a standardized and easy to use format. But of course, we can spot sometimes some rather variant results in the accuracy of the classifications. And now, as the project deals with the deep sea species that are not common knowledge, we don't have a very huge user base. We think we have quite a sufficient user base still, but it's still a limited number of people that can engage in this, and the people that we see engaged most in this are quite a small fraction of the total people that engage on the platform. However, what I see in general as a big advantage of citizen science is the scale of it. In one philosophy, citizen science enables you to get much more data than you would be able to do as a single scientist or a group of scientists. So when it comes to these questions of data validity or data quality of citizen science data and standardization, isn't it somewhere kind of a general idea that citizen science should, in theory, give you a larger data set, and within that larger data set, these presumed larger variance should even out in the end. So you should get like quantity before quality, you know what I mean? And is there someone out here somewhere who has a project where everything just has worked so very perfectly well when they scaled up their project with citizen science and can say, yes, this theory actually works somewhere, and what did you do so very right then? That's my question.
All of my projects work very brilliantly and perfectly. No, no, none of them do, obviously. I don't know who wants to answer Joel's question.
There was one of the pieces of work that we're doing, again, looking at synthesizing best practices, is we're discussing with the UN Statistics Division and the people in charge of Sustainable Development Goals. They have a lot of experience in understanding the statistical nature of sampling. And if you look at things like training data sets for machine learning and AI, I mean, one of those things that's, things are very, very sensitive to how dense the sampling is against the variation in what's being sampled. And yeah, often we have very, very poor data from official sources. I mean, things like air quality and temperature. I mean, these things are classic. Everybody riding around on a bike with a phone in their pocket is getting a better sense of what the temperature is actually like at street level. Everybody walking around than the official calibrated thing. So absolutely, there are opportunities there. But probably to realize those, we're going to have to think carefully about standardizing these expressions of the statistical nature of sampling, because if we don't do that in a systematic way, as Hugo was saying, no, if it's ad hoc, we'll just never really get trust. We'll never see those benefits. But if there was a framework that can emerge around, how to describe the value of our sampling in a more systematic way, we may be able to get better traction.
Yes, I know from experience in another project that it's hard enough to get scientists to sample in a standardized way, even though there's a standardized protocol. Well, so I get that the sampling variance can be a problem that is unsolvable with citizen science data, but still, in theory you should have a larger number of people sampling. You'll get a larger data set, and shouldn't that outweigh that in the end somewhere?
Yeah, I certainly wasn't saying it was unsolvable. I'm saying that if we had a way of describing the value that larger sample has in a more consistent way that people understood, then I think the point you're making would be more obvious.
Yeah, I've seen a number of projects that have achieved this. If you have a large number of measurements by citizens coming in from more or less the same time period and same sampling location, then it will at least be easier to identify outliers. That I've seen. But yeah, where you draw the line is always going to be difficult. Sorry, Emily, I think you had something to add.
Yeah, and this also depends on the aim of the citizen science project itself. So there are some jellyfish initiatives along the coast of France where for them, quantity does overweigh the quality of the data because they're getting so many. And in their view, the citizens who are reporting and viewing the maps of where jellyfish are just want to know where the jellyfish are. They want to know if they can go in the water or not. So, and they are a much larger participation organization than in Israel. So that has to be taken into mind, is what are the real aims that you're looking at. But I think across the board, if you're trying to create standards and guidelines among similar types of projects, what you're looking for needs to be, and what you're quantifying in your data needs to be small enough that it can kind of overreach the variances within each different project's aims.
I see we're right about out of time. I don't know what the process is usually. You're welcome, Joe. Cora or Pauline, whoever could answer, are we allowed to go another 5 minutes because there are 2 more questions? Or
oh yes, of course.
okay,
Yes,
perfect.
yes, of course.
So there are 2 questions, one from Mauricio in the chat. Considering the state of art of MSP as an economic tool, how could we instigate citizen participation in traditional communities if they do not have equity in economical incentives as other stakeholders do? Eric?
Yeah, just an initial reaction. Yeah, thanks for that question, Mauricio. I think that and I might not have been clear about this, but I think that it's the burden is on the policymakers, right? So if the policymakers want to come up with a new policy or a regulation, it's on them to actively go to the potential stakeholders to ask for input. So I'm not sure if this completely answers your question, but I think in your case, whenever a new policy comes up for marine spatial planning, for example, the people in charge will have to go to the traditional communities and ask actively for input there. And this is, for example, why Australia organized over 1,500 town halls, right? So they wanted to go everywhere to the people themselves instead of the people coming to them. So, and I think in many marine spatial planning processes, it's actually done that way. And I hope that answers your question.
Right. There's one more question from Patience in the Q&A. She says, question to Louisa or Emily. Any advice on carrying out citizen science projects, example given data collection in financially challenged regions in terms of ensuring the quality, contamination of data collected and use of incentives without influencing the collection process? After that, maybe we can take a question from Asaf. His hand is up, and then I'll wrap it up. Louisa or Emily, whoever wants. Yeah, Louisa, go ahead.
Yeah, what I did with the projects in Italy, we had very little money for this project actually, so it was only enough for consumables, and I was trying hard to convince the local administration to pay for those consumables because I didn't want to ask the citizen to, I mean, they were already giving their time, so I didn't want to ask them to even pay for the reagents that we needed to monitor water quality. So I think one point which maybe also raises the question about how can we uniform and standardize citizen science approaches is also, at least for example, within Europe, we could try to think about common European policies where those efforts, those approaches are incentivized on a national level as well by member states, so they get some funding that could be used by local administration to support those kinds of projects. In our case, it was okay, it worked, but yeah, it was not so straightforward, and Italian bureaucracy is very painful, so it was just to get 300 euros to get some consumables, we had to go through I don't know how many months of negotiations. But it worked, finally it worked. But it was really needed to have the support of the local administration also to show them that, look, this is something that can help you. And actually it did, because I mean the mayor got re-elected, so at the end it was not so bad for them.
Thank you, Louisa. Asaf, you have a question?
Yes, hello, I'm Asaf from the NGO Eco Ocean. It's more of a comment than a question, actually, but it might be also related to what was spoken here. I think the focus of the discussion here was mostly technical, but I think the social aspect should also be considered. I think Louisa mentioned that at a certain point. What we faced is a problem. The things that we work with the volunteers to do citizen science, mostly ecological citizen science on the coast and underwater. But we look at the volunteers as representatives or maybe ambassadors of the environment, more than just citizen scientists. And what we faced is a problem harnessing them to other activities and taking part in other activities than just the activity of collecting data and something they liked, like diving, for instance. So what we actually realized that we need to build a community, and that's what we think is the biggest challenge, is building a real community, active community, which the participants take part in everything, co-designing and bringing their own wishes and dreams and what they're really interested in. It's not only just about collecting data and transferring the data to scientists or decision makers, but also having ambassadors, citizen ambassadors, taking part in everything that is happening in the country in the environment. So that's another issue I think that must be considered when you're planning a citizen science campaign.
Mm-hmm. Thank you, Asaf. I think that's all, and we're already 7 minutes out of time. I'll take this opportunity to thank everyone, starting from our panelists. Thank you for your time. Thank you for everybody who joined. Before everybody leaves, I'll take the opportunity to share with you our next OTTERS event. It's going to be held on 27 November. It's going to be a online workshop on legal issues regarding citizen-generated data for the water domain. We will be discussing issues of data protection, privacy risks, challenges, autonomy, dignity, indirect discrimination, equity, cross-border character of OTTERS project going through different countries and also outside of Europe, what type of legal issues might stem there. And lastly, emerging legislation and anticipatory compliance requirements that we might need to deal with. Again, thank you very much, everyone. You can find us on different social media channels, and these are the websites of the two projects. Please follow us wherever you can, and we will have a number of different events coming up in the upcoming months in both projects. We would like to see you there as well. That said, I again thank everyone, and I wish you all a very nice afternoon or morning, wherever you are.
Thank you, Garabet. I hope everyone has a
Thanks,
good day.
Garabet.
Thank you.
Cheers all.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye.
Thanks a lot.